She's just gonna be devastated.
Don't worry. You can watch the recording. It'll be...
You got a fire stick in here?
Yeah, I gotta watch Elf today. And all my other classes except this one.
You just like log in like Netflix or something?
It's not on Netflix. I have it on my... I bought it on iTunes.
You couldn't just log in your iTunes?
Then I would have to like authorize my computer and like log into my Apple ID. I don't even know my Apple ID, I don't think, which is not good.
You should probably reset that.
Yeah. And I'm like, my phone's like 3 years old, so maybe I want to get a new phone. It's still kicking. Can you believe that? My iPhone XR. I've had it for 3 years.
I had an iPhone 7 until this year.
Oh, what's that home button?
Yeah, I love the home button.
It's embarrassing.
It's not embarrassing.
Okay, we just have a few multiple choice and then a few. I don't think it should take us that long. I won't talk that much. Okay, we'll just kind of do the problems. Here's my function. This will be on a no calculator part. They want us to find f prime of pi over 6. So you just start by finding the derivative. All right, folks. What's the derivative of tangent? Secant squared of 2x. Chain rule times 2. Don't forget about chain rule. Okay, so 2 secant squared 2x would be that straight up derivative. So f prime of pi over 6. The derivative at pi over 6, we just plug that in. 2 times pi over 6 would just be pi over 3. Well, here's a good trick question for you. Do you guys know what the secant of pi over 3 is? Yep, reciprocal cosine. Cosine is 1/2.
So do 2.
So 2, yep. Cosine of pi over 3 at 60 degrees is 1/2. So this would be 2 squared. Since it's secant squared times 2, so you get 8. E, yes. That was a fun one. Ooh, the next one. They want us to find the derivative of this. I'm going to need 2 different rules here. Definitely going to need product rule and chain rule. Okay. So here, I'll use Christmas colors. First, times the derivative of the second, which that would be power rule 3 x squared plus 2, drop 1 from the power 2 times the derivative of the inside, 2x. Plus second times the derivative of the first, which is just 1. Okay. Now, looking at my answers, I don't have any multiplied out option in standard form. So I don't want to multiply everything out. So kind of just looking, and this is just test taking strategy in general. Looking here, it's okay, I definitely see, I have some factor of x squared plus 2 kind of grouped together. So I don't want to multiply those out. So when I'm kind of simplifying this piece, the only thing I would maybe do at first is times these guys together. So I have x minus 1 times 6x. Maybe I'll put the 6x in front. Something like that. I wouldn't really go much further. Definitely don't multiply that out because I see those x squared plus 2 squareds in all my answers. And here I have just x squared plus 2 cubed. Okay, so then I look at this and I'm like, okay, what can I factor out, or what do these have in common? And they both have this x squared plus 2, so I could factor out 2 of those, because that's what's common. And with this term, if I factor that out, I'll be left with 6x times x minus 1, so I'm going to go ahead and distribute that. That's what I'd be left with there. And here I'd be left with one more factor of x squared plus 2. And then just simplify this a little bit. I get 7x squared minus 6x plus 2. I got D. Yep, that's right. So kind of check out the options. If it hasn't multiplied out in standard form, then you're going to have to obviously like multiply everything out. But if you see like that pattern, like, oh, it's still written kind of like has a product here, grouping the x squared plus 2. So that kind of give you a hint of, hey, I need to like factor that out. Oh my gosh, the next one's a related rates one. Multiple choice version. How fun. These are all no calculator, by the way. Okay, last multiple choice one for derivatives. Functions w, x, and y are differentiable with respect to time and are related by the equation w equals x squared times y. If x is decreasing at a constant rate of 1 unit per minute, so that's dx dt is decreasing -1 unit per minute, y is increasing at a constant rate, that's my dy dt of 4 units per minute. At what rate is w changing? So we want to know dw dt when x is 6 and y is 20. Okay. That's how I like to set up the related rates ones. So before I find the derivative, I have to make sure that my equation that's relating all the variables is only in terms of the ones that I have rates for or want to find. So since I have dx dt, dy dt, and dw dt, I can go ahead and find the derivative right away with respect to time. So the derivative of w is 1 dw dt. Over here, I have to use product rule. So it'd be first x squared times derivative of y, which is 1 dy dt, plus, sorry, I'm getting my colors organized, plus the second factor times the derivative of first, which would be 2x dx dt. All right, now you could like simplify this one a little bit, but we want to know dy dt, so I probably just kind of plug everything in now, plug in all my information. So I know when x is 6, so that'd be 6 squared. I know my dy dt is 4. I know my y is 20 times 2x times dx dt, which is -1. All right, now keep in mind you don't have a calculator, so this is some mental math you're going to have to do in your head here. So we have 36 times 4. So if you need to like do that multiplication, or sometimes I just do like 30 times 4, which is 120, and then 6 times 4, which is 24. So that's 144, like add them together. That's how sometimes I do my mental math. That's 144. And here I have to do 20 times 12 times -1. So 20 times 12 is 240 times -1 would be minus 240. That's not too bad. So 144 minus 240 give us what, folks? -96. And honestly, if you couldn't do that math super quickly, look at your options. It's obviously not -240 or -384. And we know it's 144 minus 240, so it can't be positive. So even if you're like, oh my gosh, is that -94? Like, just use process of elimination too. Okay, now some FRQs. What time? Okay, we have a classic two particles move along an x-axis, particle motion one. So from 0 to 6, for our time, the position of particle P is given by this cosine function. And the position of particle R, so this other particle that's moving, is given by this polynomial function. So A says, in between those 6 seconds, find all times t during which particle r is moving to the right. Moving to the right. So anytime you're asked like what direction, we need to find like the derivative or like the velocity, because velocity is speed with direction. So I want to find when r prime of t is positive, or you could say it's greater than 0, when it's positive. Then that would mean it's moving to the right. Okay, so we would start by taking that r of t, that polynomial, finding the derivative. Oh, I should add, this is another no calculator one. So that'd give us 3t squared minus 12t plus 9. So first I have to find when it's like at rest, so then I'll set up like a little sign chart, or you can think of this as like, hey, we're finding the critical point. So we want to set this equal to 0. I would divide everything by 3. Factor. We get 1 and 3 seconds is when it's at rest. Okay. So if I were to make a little signs chart, right here. Remember, we're plugging them into the derivative. So again, this part you're gonna have to like do without a calculator. Now you could technically plug in 0. That would be a really easy one. 0 plus 9 would give us a positive. Okay, if you plug in 2, you have 12 minus 24 plus 9. That's going to give us a negative value. Then if I plug in something like 4, I have 16 times 3 minus 12 times 4 plus 9. That's going to give us a positive value. So that you kind of have to do like mentally in your head. You don't have your calculator for this. Okay, so we know our particle is moving to the right anytime we have a positive velocity. So I would just say r of t, or you could say particle r, is moving right for 2 time intervals. I'm going to list it in this notation since that's what they did. From 0 to 1. You don't want to include 0 or 1 because technically it's at rest with 1. And from 3 to 6, because this doesn't go on forever. And you could cap it at 6 like this if you wanted to. And 3 to 6, since the derivative is positive on those intervals. Okay. That's my answer for part A. Part B says find all times t during which the two particles travel in opposite directions. So we already know what direction particle r is doing for the 6 seconds, right, left. So now I just have to do the same for particle p, which has my cosine function. So let's start by finding the derivative, which would be, let's see, negative 2 sine of pi over 4t chain rule times pi over 4. I feel like I gave you guys one like this on a test one time, and a lot of you forgot chain rule with that. Like, I think it was like pi over 12 was inside. Okay, and the 2 just carries down. Derivative cosine is negative sine. So that's why it's negative 2. All right, so I would just simplify that to like negative pi over 2 sine of pi over 4 t. And I need to figure out where this is 0 and create a sign chart for this one. So technically you could divide off like that negative pi over 2 constant on both sides, and we get here. Okay, so the 2 times that sign is 0 is here and here. So at 0 and at pi. So I would set this equal to when that angle is 0 4 when that angle is pi. I don't know how you guys were taught to solve trig equations. This is how I would solve it. So that'd be at 0. Divide both sides by pi over 4. That'd be at 4 seconds. Or times by 4 over pi, whatever you need to do. So that's when particle P is at rest. So if we create a chart for this one, the only one we have to look at is 4. This one might be a little bit more challenging to plug into the derivative because I can't plug in 0. We could plug in 1. And I know that the sign of pi over 4 is positive times a negative. It's going to give me negative. Okay, follow my thinking there. I could plug in. No, I can't plug in 8. I could plug in 5. Sine of 5 pi over 4. That's down here. Is negative times negative pi over 2 is positive. Okay, follow my thinking there. Again, you have to do this out your calculator. So I was going to plug in 8 to make that a nice 2 pi, but I realized that's not my interval. We're only going from 0 to 6. So you'd have to plug in like 5 or something. Okay. So at what points are they traveling in the same direction? I'm running out of room here, but it looks like, well, from 0 to 1, this one's going to the right. And from 0 to 1, this one's going to the left. But then from 1 to 3, this one switches direction and it's moving to the left, and so is this one. So then at 3, switching back to the right. This one doesn't switch back to the right at 4. We want to know when they're traveling in opposite directions. Oh, for some reason I thought it was the same. Opposite direction. So right away from 0 to 1. Bless you. Zero to 1. And it would look like from 3 to 4. Okay. Are we okay with that? Don't worry, we have 17 more minutes of fun. Guys, this is our last Calc lesson of 2021.
There's always next year.
So glad we could spend this time together. Okay, on the next FRQ, we're able to do A, B, and C. That's really exciting. Kind of worked. I do this all the time now.
Erase your markers. Oh.
Here's your markers. Okay. Ooh, that's exciting. Look, on an FRQ, the first thing it says, find the derivative. No problem. I would maybe just write this radical as an exponent before doing so. Maybe look at the squaring rubric for this one if you want, since we can do 3 parts. All right, so power rule, 1/2, dropping from the exponent, don't worry about chain rule, times the derivative of the inside, negative 2x. These 1/2 and 2, that's just 1. So simplify the negative exponents by putting that in the bottom. And we have negative x up top. That'd be it. Here's my derivative. Wonder how many points that was worth. Probably 1. Probably 1 of 9. Part B says, write an equation for the line tangent to the graph of f at x equals negative 3. We need 2 things to write equations of the line. The slope of the tangent line, which is f prime of negative 3. And we need the actual point, which is negative 3 comma something. We'll be able to figure that out. Those are the 2 things you need to write the equation of the tangent line, and then you can just leave it like in that point slope form. So let's start with finding the slope of the tangent line because you have the derivative right here. So all I have to do is find f prime of -3. So if you didn't know how to find the derivative in part A, this would kind of be hard to do part B. This is another no calc. All right, to get +3, 25 minus 9 is 16. So we get 3/4 for the slope. To find the point, just plug it into the original function here, which could probably do this in your head, but since this is an FRQ, we should show our work here. We get 4. Square root of 16 is 4. So we have the point -3, 4. All right, so to write the equation of the tangent line, point slope form, y minus y1 is 4 equals m. The slope is 3/4. We use the derivative to find that. X minus x1, which is -3, so +3, and then you can just leave your answer like that. Not bad. Oh, part C is a throwback. Let g be the function defined by this piecewise function, where it's f of x for every x value in between -5 and -3, and it's x plus 7 for every x value in between -3 and 5. Is g continuous at x equals -3? We see we have this break right here. So is it continuous? Use the definition of continuity to explain your answer. Do you guys remember the definition of continuity? Yep. Okay, so it's like that I, double I, triple I. So the second thing you have to check is that the limit is the same. The first thing we have to check is that it's even defined at this value, that g of -3 exists. Okay, that we don't have like an undefined value here. So first you have to show that g of -3 exists. So I would use this piece, which is f of -3, which we already found that is 4. Okay, that exists. The output at -3 is 4. The second thing, you have to check the left and the right-hand limit, and you have to make sure they're approaching the same thing. So that's like my double I. You have to check the limit as x approaches -3 from the left. Has to be the same as the limit as x approaches -3 from the right of g of x. Okay, so looking at my two pieces, as x approaches -3 from the left, I would use this piece, f of x. And as the limit, as x approaches -3 from the right, I would use this piece, x plus 7. So to find limits, we can just do that direct substitution. So this is the same as f of -3. This is the same as -3 plus 7. We already found this is 4. -3 plus 7, that's 4. So the limit as x approaches -3 of g of x is 4, since the left and the right equal the same thing. All right, the third thing we have to show, I'm going to come up here because I ran out of room. The third thing we have to show is that these are equal to each other. That g of -3, the output, is the same as what the limit is approaching. Okay, so we showed that this is 4 in step 1. We showed that this is 4. Therefore, g is continuous at x equals -3. Yay, we like the continuity. G is continuous at x equals -3. I feel like I said 4. I can't remember what I said now. That's a good throwback. Okay, folks, we only have one more to do on this fine day, December 23rd, Christmas Eve. Rita. Okay. Okay, hey, just really quick though, look at part D. Does that symbol look familiar? That's what we're gonna do when we come back from Christmas. We'll be able to do all the parts. If I got an FRQ like that, I feel like I'd be like, nice. Nice. That one was not too bad. Did I delete arrow C? We actually can't do this one yet. I think I originally thought we could. We cannot. Bye. Okay. So this one, another no calculator. The function f is defined on the closed interval from -5 to 4. The graph of f consists of 3 line segments and is shown in the figure above. Let g be defined by this step. Okay, we don't know this part yet. That's why we can't do any of these parts that involve g. But we can do part D. We don't know those integrals yet. Okay. D says the function p is defined by p of x is f of x squared minus x. Find the slope of the line tangent to the graph of p at the point where x equals -1. All right. Slope of the line at a point, instantaneous rate of change. I gotta find the derivative and plug in -1. So let's find the derivative of p. P prime of x. Okay, this is a composite function. So think of this as like chain rule. I gotta do derivative of the outside times chain rule times the derivative of the inside, which would be 2x minus 1. Okay, now don't worry too much about this notation. Go ahead and plug in. We want to find it at -1, and you can, plug that in really at any point. So you got to find f prime of -1 squared minus -1 times 2 times -1 minus 1. Alrighty. So this piece, you're finding f prime of, simplify just that inside, so you have 1 minus -1, you got 2. So you got to find f prime of 2. And then this piece is we're going to times it by, maybe it'd help to add in a multiplication symbol, times it by 2 times -1 minus 1 would be -3. All right, so f prime of 2, I'm going to have to go to my graph. That's asking for what's the rate of change at 2, aka what's the slope at 2. Here's my point at 2, so it's these 3 line segments. So what's the slope at that point? So you can either kind of go like down and over here, or you can go this way. Counting my rise over run, I did 4 over 2. Oh. 4 over 2, or -4 over 2, I should say. So -2 is the slope there, times -3, so we get 6. Would be the answer there. Okay, that's all. I'm going to pull up the scoring rubric from that last one, that question 4 that we could do 3 parts just so you can get an idea right now. I can find it. Here. This was from the 2012 exam. Oh, 2 points for finding the derivative. Nice. Part B, 1 point for finding f prime of -3, the slope, 1 point for your answer. Here, considers one-sided limits, so showing like the left and the right-hand limits are the same. Answer with explanation, that's probably like showing the definition of continuity. So you could have got 6 out of 9 points for that. Here's an example response from a kid who took this exam. This is how it's like broken down. It'd be like in boxes like this. That's a weird way to find that derivative. It was like looking at his work. Anyways. Or I don't know if it's a he, I guess. This one's pretty. Integrals will do that. So yeah, some sample response here. Not a lot of work shown. Okay, anywho. We'll call it a day. You can also see it's kind of